We need to find the complete integral of this equation. It is very important question. We were discussing the example on the standard form 1. What is the standard form 1? It is the equation of the form fpq to be equal to 0. The equation involving only p and q variables, right? But here I am having x, here I am having y and also z. What to do now? I need to change this equation into this format. For that, let's understand some remarks. We know that small p is partial derivative of z with respect to x. Our z is the function in x and y, right? It depends upon the variable x and y. We are taking our small p to be equal to the partial derivative of z with respect to x and q to be equal to partial derivative of z with respect to y. What are capital P and capital Q? If we take u to be equal to log x, v to be equal to log y and w to be equal to log z, then this small p can be written as it is partial derivative of z with respect to x, which can be further written as, if I apply the chain rule, the partial derivative of z with respect to w and then the partial derivative of w with respect to u and then the partial derivative of u with respect to x, right? So this is equal to what is partial derivative of z with respect to w? From here I get z to be equal to e the power w. So partial derivative of z with respect to w will be e the power w only, right? That is again z. So this is z into, let me write this as it is, and here the partial derivative of u with respect to x, that is 1 by x. So let me take z by x together and this to be taken as capital P. So I am taking the partial derivative of w with respect to u to be the capital P. So when we consider u, v and w in log x, log y, log z respectively, and then from small p we are introducing this capital P to be partial derivative of w with respect to u. Similarly, the capital Q will become the partial derivative of w with respect to v, right? So for this capital Q, we need to take the small q to be equal to partial derivative of z with respect to y, which can be further written as the partial derivative of z with respect to w, the partial derivative of w with respect to v, and then the partial derivative of v with respect to y. This is, we have solved, this is z. Let me write this as it is, and the partial derivative of v with respect to y will be 1 divided by y. So this is 1 by y. Taking z by y together and introducing capital Q to be partial derivative of w with respect to v. The partial derivative of w with respect to v. So you have to take the capital P to be the partial derivative of w with respect to u and capital Q to be the partial derivative of w with respect to v. Please remember these two. So after getting our capital P and capital Q, our original equation will be changed into the function of capital PQ. The equation takes the format in P and Q, capital P and Q. And then again we consider the capital P to be equal to the constant A, and from here we get the value of Q in terms of A, and then instead of using dz equal to P dx plus Q dy, we don't need to take this. Instead of this we need to take dw to be equal to capital P du plus capital Q dv, right? So consider this equation and then solve for the complete integral. Let's move on to the solution now. Since this is our given equation, and we have small p to be equal to z divided by x into capital P, right? And small q will be equal to z divided by y into capital Q. Very fine. All right. Can I write this equation to be? It is x square. What is small p? It is z divided by x into p, right? So it is z square divided by x square into capital P square plus y square, and q square becomes z square divided by y square into capital Q square equals to z square. So you have to remember this. Then these two cancelled out and we are getting, taking if z square outside, this is capital P square plus q square to be equal to z square, and then from here we get capital P square plus q square equal to 1. So this is the equation in the format in P and Q only, right? So to solve this equation, which is the standard form 1, we always take capital P to be equal to the constant A. A is a constant. So putting this constant in the given equation, so we get a square plus q square equal to 1. From here I get q square to be equal to 1 minus a square, and capital Q will be square root of 1 minus a square. So I got the value of q, I also get the value of p, right? And now I am going to use the equation dw to be equal to capital P du plus capital Q dv. Now putting the values of p and q over here, we get, this is a du plus the square root of 1 minus a square dv. This is dw, and now integrating we get w to be equal to au plus square root of 1 minus a square is constant, and this is v, plus the constant b, right? B is a constant. And now we are going to put back all the values of u, v and w. So in the left hand side I'm having w, so writing here log of z equals to a into u. So a into u, that is log of x, plus the square root of 1 minus a square into v, that is log of y, plus the constant b. So from here I get log of z to be equal to, it is log of x the power a plus the log of y the power square root of 1 minus a square, and let me take the constant b to be log of c. So this is log of z equal to, according to the property of logs, all these are multiplied together, the log of these three products, and from here we get z equal to x the power a, y the power square root of 1 minus a square into c, where b is equal to log c, the constant is the constant. So this is the required complete integral of the given equation. So in this way we can get the format of the given equation in the standard form 1 by applying these three considerations, and from here we are getting these results, and after getting these results just put this value back into the given equation. You just need to get your capital P and capital Q, right? So in the exam you have to write this complete remark first. You have to consider first what is u, v and w, and after that define your small p to be partial derivative of z with respect to x, and from here get your capital P and also the capital Q, and then use the given equation to get this format, right, equal to 0, sorry, this format, right, and then get your complete integral by using this equation. And after, at last, put all these values back together, put all these values back in x, y and z. Very fine. Okay, thank you.